If you remember when we started graphing quadratics, we talked about the parent graph for quadratic functions. And the parent graph is just the basic function y equals x squared. Okay, we call this the parent graph for quadratic equations. There's nothing really changing this, it's just the basic y equals x squared. And to graph this, we made a little chart. And I'm just going to use a few points for today, so I'll just use 0, 1, and 2. And we plug in 0 in for x into each of these, and we said that 0 squared was 0, and 1 squared was 1, and 2 squared was 4. And we ended up with a graph that looked kind of like this. If we plot 0, 0, that was our vertex, we said. We had 1, 1, and we had 2, 4. And I also picked the points -1 and -2 as well, but we also now know that the axis of symmetry that goes through the vertex is going to reflect these points across the axis of symmetry. So we really only need those 3 points. We can reflect the 2 of them so that we can kind of complete the graph. And this basic graph of y equals x squared is going to be a good starting point for this new form we're going to talk about called Vertex Form, which is going to help us shift things around. It might be a preferred method for some people to graph these. So we'll jump down here to Vertex Form, and this is Vertex Form right here. So anything that's in this first little set of parentheses here, this x minus h, whatever makes the inside of that parentheses equal to 0 is going to shift the graph. So it shifts the graph left or right. Okay, so it's going to shift your basic y equals x squared parabola left or right. This plus k here, okay, so whatever this comes out to be, this is going to shift the graph, kind of like when we did absolute values. And I actually recommend you maybe go back and watch the absolute value graph shifting video to see how this is all connected. So this shifts the graph up or down. Sorry, I'm running out of space there. And this part, this A right here, is going to stretch or compress the graph. Okay, and when we say stretch or compress, if A is going to be, if the absolute value of A is going to be some number that's greater than 1, it's going to make the graph tall and skinny. And if it's some number that is less than 1, it's going to make it kind of wider. So if you had like a half or a third for A, that would give you a kind of a wide graph there, whereas if you have 2 or -2, that'll make the graph tall and skinny. And it also can flip too. So it can flip the graph if it's negative, so it could turn it upside down, or it can make it stretch or compress. So let's get right to some examples here. So if we look at this first graph of y equals x minus 2 squared minus 3, we can see first off that the graph is shifted left or right, and it's going to be shifted up or down. There's no number in front of this squared term, so it's not going to get flipped or stretched or compressed. So I'm just going to start by graphing my parent function here. And this is something hopefully you can kind of eventually memorize, but this is the basic parabola graph, and if you're not sure how I'm getting this, just you can rewind a little bit to see how I came up with that graph. This would be the graph of y equals x squared. And what I'm going to do now is, since this graph is going to be shifted, and in this case what makes this 0 is going to be 2, so that's going to move me, since that's positive, right 2 and down 3. I'm going to move each of these points right 2, so we'll go right 2 here and down 3. And you notice here that the vertex, the reason this is called vertex form is because whatever makes this 0 and however that gets shifted down is going to end up being where the vertex is. So again, I'm going to take each of these points, I'm going to move it right 2, down 3, right 2, down 3, right 2, down 3, and we'll take this one right 2 and down 3. And again, you can see now that we've got that graph of the parabola. And this vertex form is a little bit easier. You don't have to use your negative b over 2a formula. It's sort of like, I think of it kind of like a slope-intercept form in that it's a little bit easier to graph than just when you're graphing a line. Okay, so let's take this next example here. And again, I'm going to start with the basic parent function, which is y equals x squared. I'm going to graph that first. You'll be pretty quick at graphing this here with a few of these examples. So there's the basic graph of the parabola. And I can also now see, and I'll get to this in a second, that the vertex, what would make that 0 is -1, and the y-coordinate here would be 6. So I can already see that the vertex is at -1, 6. It's pretty quick to get that when you're in vertex form. That tells me that this graph is going to shift right 1 and up 6. Okay. Now, before I get to that, though, I should always take care of this A part first. So what I'm going to do is actually, before I try to shift things around, I'm going to flip this graph upside down. So anytime I have a negative out front for the A, the graph gets reflected over the x-axis. So what we're going to do is just reflect the parent function. So instead of opening upwards, it's going to open downwards. So we'll reflect this graph over the x-axis. And there it is. So now the green dots are where I'm at now. And now from the green dots, we're going to shift everything, since it's -1, left 1, and up 6. So we're going to go left 1 and up 6. We'll go left 1 and up 6. 1, 2, 3, 4, 5, 6. And we're just going to do that for all of these points. And I'll fill these in here. I'll let you count this on your own to double check me, but you might just kind of realize the shape is going to stay exactly the same. So the points should be kind of spaced out the exact same way. I don't know why these points are disappearing here either, but so that would be our kind of U shape for this parabola. Okay.
Please excuse me.
So that takes us, we'll go to 2 more examples here. One of them we'll do in vertex form, and the other one I'm going to actually take a standard form equation and I'm going to graph it using the thinking that we just did behind vertex form. So I'm going to try and connect the 2 forms here in a little bit. So we've got 2x squared minus 8, and again, this may not look like vertex form because you don't see the parentheses, but what that means is that the h here is just 0. We've got x minus 0 squared, so we just have a plain old x squared here. So when we're doing this one, again, I'm going to start with the basic parent function graph. We'll do that first. And now what we're going to do is first, again, start with the A here. The A is 2. So what that's going to do is that's going to stretch this graph by a factor of 2, meaning instead of getting wider or staying the same or something like that, it's going to get tall and skinny. So it's going to look something like this instead of going wider. So if it was something like 1/2 or 1/3, it would look more like this graph, but since it's a number that's where the absolute value is greater than 1, this number is going to stretch the graph vertically. So what we're going to do now is if you think about what the parent function for this graph was, and I'll make this chart here real quick. We had 0, 1, and 2, and this point was 0, 0, we had 1, 1, and we had 2, 4. What happens when we stretch the graph is we're just going to, since this is a 2 out front, we're going to double all the y values. So 0 would become 0, so if we multiply by 2, we're going to get 0. If we double the 1 here, we're going to get 2. And if we double the 4, we're going to get 8. So this should take me through all the different things I need to do to stretch this graph. So now what I'm going to do is regraph this using the point 0, 0. That's already on there. Instead of the point 1, 1, I'm going to basically double this distance. Before it was 1 above the x-axis, now it's going to be 2 above the x-axis. Okay, and if we look at this one before was 4 above the x-axis. Now it's going to be, I think it'd be right here, 1, 2, 3, another 4. So 8 above the x-axis. So that'll be right up here. And now if we reflect these things across the axis of symmetry, you can see that here would be our U shape in our parabola. So this is going to be the beginning. And now there's no left or right shift because there's no x minus something in parentheses, but this minus 8 here is going to take each of these red points and move them down 8. So if we make the vertex 1, 2, 3, 4, 5, 6, 7, 8, so that'll put us here. And then again, I'm just going to keep the same exact shape that we have in the red. This would be up 8 from here. 1, 2, 3, 4, 5, 6, 7, 8. And again, if that's confusing you, you can count down from each of the red points and make them 8, if you would like to do it that way. But when I connect the dots, that should be the U-shaped parabola right there. Notice that it got skinnier than the parent function because of that 2 out front. All right. So one more graph here. We're going to take this one and we're going to use vertex form to graph this, even though it's in standard form. We'll still use some of that thinking behind this. So I'm going to start by doing negative b over 2a, just like I would before if I was graphing one of these standard form parabolas. So this would be negative 4 over negative 2 times 1, 2 times 2, so 2a. Let me fix that here real quick, just so I don't confuse people. Technically, it should be 2 times negative 2. So negative b over 2a, so x is going to equal, in this case, 1. So if we divide that, 4 over negative 4 over negative 4 is 1. So if we plug this in, we get 1 comma something. We'll plug the 1 in to find out what that something is. So if we plug in 1 into the function, when we plug in 1, it looks like we're coming out with another 1. Yep, so it'd be 4 minus 3, which is 1. So if you plug that 1 in, you get to 0.11. That tells us that the vertex is at 1, 1. Okay, now this number out front here, this negative 2, is going to tell us how the graph is shifted, okay, or excuse me, how the graph is stretched or compressed. So in this case, first off, it's going to get flipped upside down. So this parabola is going to open downwards. And not only that, it's actually going to get stretched by a factor of 2 now that we have this here. So we're going to double the distance between the vertex. So this was 1 away from the vertex. Now it's going to be 2 away from the vertex. And, oops, maybe I miscounted here. 1, 2, 3. No, that's right. So this was 4 away from the vertex in the y direction. So now it's going to be 8 away from the vertex in the y direction. 1, 2, 3, 4. 1, 2, 3, 4. And then our final graph is going to be here in green, this sort of U-shaped parabola going like this. So the number in front of the x squared is still going to function like the a out here. And to find the shift, the h and the k shift, we just have to find the vertex. So actually, I could rewrite this in vertex form by writing it as y equals, the a was negative 2, that goes out front. You know what, I'm going to run out of space here. Let me sneak it down here. We're going to have negative 2 times x minus 1, it was shifted 1 to the right, and then plus 1 because it was shifted up 1. And that would actually be, if we sneak a squared in here, that would actually be vertex form for that parabola. Okay, so this is just, again, kind of a mix of different types of problems. I kept mostly with vertex form, but I wanted to show you that you can still use that thinking for regular parabolas that are not in vertex form.